Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about how we can use the quotient rule to find the derivatives of the other four trig functions that we haven't taken derivatives yet. So if we look at the calculator here, we have tangent of x, that equals sine of x over cosine x, and using the quotient rule, remember the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom. And that's going to be cosine x times cosine x minus sine x times negative sine x. And then we need to divide by the bottom squared. So divided by cosine squared x. And then the top can be written as cosine squared x plus sine squared x, which, based on trig identities, that equals 1. So the derivative of tangent of x is 1 over cosine squared x, which is also secant squared x. Now for cotangent of x, we can do a similar thing, but this time it's cosine over sine. And to take the derivative, again, we use the quotient rule. And that's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And then we can also simplify this to minus sine squared x minus cosine squared x, which is negative 1. So we have negative 1 over sine squared x, or negative cosecant squared x. Now onto secant x. We have 1 over cosine x. And for the derivative, we have cosine x times the derivative of 1, which is 0. So that can go away. Minus 1 times the derivative of cosine x. That's negative 1 times negative sine x. So sine x over cos squared x. And we can expand that out to get sine of x over cosine x times 1 over cosine x. And that's going to be tangent of x times secant of x. And then finally cosecant x, it's going to equal 1 over sine x. And then the quotient rule, sine of x times 0 minus 1 times cosine x over sine squared x. So we have minus cosine x over sine squared x. And then we can factor out a sine x to get this expression. And this equals negative cotangent, and this is cosecant. So that's the derivative of cosecant x. It's negative cotangent x times cosecant x. And here are all the derivatives of the trig functions that we found out. So you can write these down. I'll give you a second to write these down. And now let's look at some practice problems. So Jackie is flying on the graph of tangent x. What is the slope of her flight at x equals pi over 3? Well, first we're going to take the derivative. So we want j prime of x, as always. So we have j prime of x. And if you remember, the derivative of tangent x is secant squared x. So now we want to find j prime of pi over 3. So we want to find secant squared of pi over 3. So we can rewrite that derivative as 1 over cosine squared x, or 1 over cosine x squared. And the cosine of pi over 3, you know, from the unit circle, that's 1/2. So 1 over cosine of pi over 3, which is the secant of pi over 3, that's going to be 2. So secant squared of pi over 3, it's going to be 4. So j prime of pi over 3 is 4, and that's the slope of Jackie's flight. Now the next problem. Shadow is flying on the x-axis, and his x position at time t is t squared secant t. How fast is he flying at t equals pi over 4? Well, first we're going to do s prime of x, and we actually need to use the product rule here as well, because we have t squared and secant t. So we have f prime g plus g prime f, and in that case it's going to be 2t secant t plus t squared tangent t secant t. And now we're going to find his speed at t equals pi over 4, so we want to find s prime of pi over 4. So immediately we have 2t, so 2 times pi over 4, that's going to be pi over 2, and we're going to multiply that by the secant of pi over 4, which is 1 over cosine pi over 4. And we know that cosine pi over 4 is square root of 2 over 2. So this first part is going to be pi over 2 times 2 over square root of 2, or just pi over square root of 2. And then now we're going to add t squared. So that's pi over 4 squared, or pi squared over 16. And we're going to multiply that by the tangent of pi over 4. And you might remember that the tangent of pi over 4 is 1, because cosine of pi over 4 and sine of pi over 4 are both square root of 2 over 2. So the tangent of pi over 4 is going to be 1. And then the secant of pi over 4, we already calculated that. It's 2 over square root of 2. So we have pi squared over 16 times 2 over square root of 2, or pi squared over 8 square root of 2. And that's going to be shadow's velocity at t equals pi over 4. So that's it for today, and I'll see you next time.